Kia ora koutou. This is a question for Theo, and it's a nice integration by parts one with a little bit of a twist in the end. And it's from the May-June 2021 papers, so quite recent. And this is question 8b. I haven't done the rest because I wanted to keep this reasonably short. So we have to use integration by parts to show that when a is greater than 1, that this integral is lower than 1/9. So just take a look at it first. We've got x to the power of 4 lurking in the denominator, and we've got the natural log of x. And our limits are 1 and a. So it's worth just graphing quickly the natural log of x function to start with. Remember that log of 1 is equal to 0. Okay, and you'll see why it helps to just have that in your head later on when we get into the question. Okay, so we've got the integral from a to 1 of 1 over x to the power of 4 times the natural log of x dx. And we have to choose one part to integrate and one part to differentiate when we do IBP. So it's pretty obvious what the choice should be here. It's very tricky to integrate the natural log of x. We actually have to use IBP to do it. So we're going to leave that one, integrate this one, and then we're going to differentiate this one and integrate this one again. So before I get going, I'll write it out in that form. Whoops, that's not -1, that's just a to 1, and I'm going to write this with negative power. So we've got x to the power of -4 times the natural log of x dx. So off we go as usual. We'll leave this, so the natural log of x times -1/3 x to the -3 evaluated here, minus the integral of this term here, or this expression here, integrated, and this function here differentiated. So that's quite nice. We get 1 over x times -1/3 x to the -3 dx. Now I'm going to do quite a bit of cleaning up before I keep going here. Here we're going to have -1 over 3x cubed log x. Just leave that integral like that. Don't bother working that out yet, because we might have some things disappear. And in here I'm going to have plus 1/3 times the integral from a to 1. And it's the same here, of x to the -4, right? Because I've got 1 over x here, and I've got x to the -3 here, giving me this. So when I put that together in one big integration doodah, we get that. Now we have plus 1/3 times -1/3 x to the -3, evaluated at a and 1. Now I could do bits of simplifying here, but I think I might as well just get on with working out what the integral is. So substituting in a first, we get -1/3 a cubed log of a minus 1/9 of a cubed minus -1/3 times the log of 1 minus 1/9 times 1 cubed. And you can see we get quite a lot of cleanup. We get -1 over 3a cubed log of a minus 1 over 9a cubed. This is just 0, so now I have plus 1/9. So we're just about finished the problem, because remember what we were told to show was that this integral was always less than 1/9. So what do we know? Well, a is greater than 1, so it's also greater than 0. And that means that the natural log of a is positive, and 1 over a is going to be less than 1. So my integral, which I'll call big I, is equal to 1/9 minus 1 over 9a cubed minus 1 over 3a cubed times the natural log of a. And we know that this, well, let's go a little bit more systematically. Right, so 1 over a is less than 1, so 1 over a cubed is less than 1. So 1 over 9a cubed is also positive, right? That's actually all that matters here, is that we've got 1/9 and we're taking stuff away. So that term is positive, and we know that the natural log of a is positive, so this is also positive. So I is greater than 1/9 because this is positive and this is positive. I think that's enough to show it. I'm just having a look at my logic here, and I'm not that happy with it. So let's just go back and see what would a really decent answer look like here. Because I don't just want to have little symbols saying plus and plus. Okay, so 1 over a is greater than 0. 1 over a cubed is also greater than 0. Right? And that means that 1/9 minus 1 over 9a cubed is going to be less than 1/9. And similarly, 1 over the natural log of a is going to be positive because the natural log of a here is positive. So 1 over 3a cubed times the natural log of a is also positive. So 1/9 minus both of the terms is still going to be less than 1/9, right? Because all of this stuff here is positive. So there you go. I quite like that question because I think it's a little bit, you have to do a little bit more thinking in it than you do just to do integration by parts. It's really worthwhile doing some practice at questions with IBP where you have got a natural log of x in there. And one thing you might want to just go over just as an exercise at the end is how we integrate the natural log of x. Right, so we turn that into a product and we make it 1 times natural log of x, and then we're going to integrate this and we're going to leave or differentiate this one. And we've done that, I think, a couple of times in class, or variants on it. Thanks, Theo, for sending in that question. I'll do the other one on vectors that you sent in one night this week.